Hello, Math 006. In 10.5, we are looking at expressions containing several radical terms. This top part is very similar to what we talked about in the last section, just saying that we're talking about that there's no negative quantities in under the radicals and also no denominators or zero. What we're talking about today, though, and what we're looking at is more specifically adding and subtracting radical expressions. In the last section, we looked at multiplying, or a couple sections ago, we looked at multiplying them. Now we're going to be looking at adding and subtracting. The first thing here, when are radical expressions said to be like radicals? They are considered to be like radicals if they have exactly the same index and radicand. So it has to be the same index and the same radicand, meaning the number underneath the radical and the index have to be the same. So determine whether your following examples are like radicals. Square root of 3 and square root of 5. No, because the radicands are not the same. The next one, square root of 7 and the cubed root of 7. Well, they're both 7s, but their indexes are not the same, so no. Top of the next column, 4 square root of 2 and 9 square root of 2. Yes, because they both have a square root with a 2. We're not concerned with the number out front. And the next one, we have 8 to the 4th root of 6 and 6 to the 4th root of 8. And that would be no, because they're not the same radicand inside. Then what we're going to do is we're going to treat these problems very similar to as if this radicand was a variable. For example, this up here, looking at this one, 4 root 2 and 9 root 2, if we were to change that to 4x and 9x, it's going to be representing the same idea here, and we're going to add them together and subtract them in the same way. So this first one, combine like radicals. So we can see here that they both have the square root of 2. So what we're actually going to do to see why this all works out is we're going to factor out the square root of 2, just like we'd factor out an x or whatever it may be. And you can see that factor is right there. So what we're left with then is an 8 plus 3, which is 11 root 2. When we say verify in the calculator, we want to make sure you're typing all of this right onto the calculator. So type 8 square root of 2 plus 3 square root of 2, hit enter. And then type 11 square root of 2, hit enter again, and you should get the same exact decimal. Now, the nice thing about that, being able to use the calculator, is when you're working through all of these simplifying problems, you can always check them using the calculator so you know if you got it right or wrong. So the first one, I'll do 2 with you and then I'll let you work through the other 2 on your own. Let's start with number 3. So we have 9 to the 4th root of x minus 3 to the 4th root of x. Again, we want to keep in mind that this would be very similar to just having a variable. And when you just have a variable, you could work through the whole process, and I will do it for this one, of factoring out that 4th root of x, and then just leaving it with the coefficients, which would be 9 minus 3. 9 minus 3 is going to be 6 times the 4th root of x. When you're adding or subtracting, the radical does not change at all, just looking at the coefficients in front of it. And let's also look at, we'll just go to number 2. I want to let you do 1 and 4. So looking at number 2, again, we're just looking at their coefficients. So we don't really even need to do another step here. Just think 14 minus 6. Well, 14 minus 6 is going to give us an 8, and then we keep the same cube root of 2. Again, we get that 8 from 14 minus 6. Now, I want you to try out 1 and 4 on your own. Now, when you look at number 4, you'll notice that you have 2 different kinds. You have the one kind that has a square root of 7s, and then you have one that has a cube root of 11. So go ahead, try 1 and 4. Okay, you can see your answers for number 1. You have to do 4 plus 2 is 6 times the square root of 7. Number 4, the first thing I did is use the commutative law to reorder them. So I put my ones that have the square root of 7 next to each other, and then my cube root of 11. You'll notice that this one right here did not have a coefficient, so we just fill it in with a 1 like we normally would if it was just a variable by itself. And then 5 and 1 is 6 times the square root of 7. And then we have a negative 8 and plus 9. Negative 8 plus 9 is 1, cube root of 13. Okay, so now the next one we have to do is we need to simplify by combining if possible, verify in the calculator. Again, you should be checking all of these on the calculator. type in your original into the calculator, type in your answer, and you should get the same value. Ones that have something like an x, you can fill in any value for x. All right, now, when we look at these, you ask, okay, you say, well, I can't add them together because they're not the same. Here we have a square root of 8, square root of 2, but we'll notice that we can simplify this first because we know that in the square root of 8, it has a perfect square in it of 4. So you could rewrite this as 3 times the square root of 4 times the square root of 2 minus 5 root 2. We know the square root of 4 is equal to a 2, and then we have that square root of 2 minus 5 root 2. Just keep simplifying. This would be 6 root 2 minus 5 root 2. So 6 minus 5 is 1, so just the square root of 2. Again, you want to make sure you type this into your calculator and then type this, and you'll get the same decimal. If you do not, then that means you made a mistake. All right, so let's go ahead and work through one more of these together, then I'll let you do the other two. Let's look at number 7. We have cube roots here. So the first one, we have the cube root of 27, we know is just 3, minus 5 times the cube root of 8. The cube root of 8 is 2. So this should just be 3 minus 10, which is going to be a negative 7 here. Again, verify using the calculator. Okay, so now what I want you to do is look at numbers 6 and 7. Again, you'll need to simplify each radical first before you can add these or subtract. Remember, in order to add or subtract, you have to have the same index and the same radicand. So go ahead and try those. Okay, you can see my answers. Let's see, on number 6, you work through this, and we get 58 root 3. And number 8, you get 41 root 2. So you can go ahead, check all my work. Just be very careful. Probably the step that we make the most mistakes on is going to be from here to here. We have 5 times the square root of 4 and 3. I just rewrote square root of 12 as 4 and 3, and 27 is 9 and 3. We know the square root of 4 is 2, the square root of 9 is 3. That's where those numbers are coming from. Okay, going on to the next page. The next thing, products of 2 or more radical terms. What law would you use to simplify this? If you're unsure, think of it looking like this. If you had x times 5 plus x, what would you do? Right, we would distribute. So this we'd use the distributive law. So now this first one, multiply, verify on the calculator. Again, all of these you can type it in just as you see on the calculator. Use the parentheses above the 8 and 9 to check your answers. We want to distribute this. So we have to take the square root of 7 times 3, which would be 3 times the square root of 7. You cannot multiply those numbers together since one is under a radical and one is not. And then we're subtracting the square root of 7 times the square root of 7. Again, if you're multiplying a square root times a square root, you're multiplying what's inside as the radical, or the radicand. So it'd be 49, which we know the square root of 49 is going to be a 7. So 3 root 7 minus 7. And we can't simplify that any further because one has a radical, one does not. So we just leave it like that. We would think of those as not like terms. So for example, you could think of that as something like 3x minus 7. You cannot do that, so we can't do that. Okay, let's see. Let's look at, I'm going to skip down to, let's look at number 13 here. So number 13, now we have a binomial multiplied by a binomial. This is where you have to FOIL, if you will, where we need to take this first one and distribute it to both of the terms in the second. So multiplying 4 root 3 times 3, which would be 4 times the square root of 9, and then minus 4 root 3 times 5 root 2. So 4 times 5 is 20. Root 3 times root 2 is 6. Now we have to take the other one. So root 2 times root 3 would be root 6. And then root 2 would be a 5 root 4. Again, when you're multiplying, they just have to have the same index. Adding or subtracting, the index and the radicand have to be the same. Now we need to simplify this. Well, we know the square, so looking here, the square root of 9 is 3. So 4 times 3 gives us 12. Now, the middle two terms are going to be like terms because they both have the same radical. So negative 20 plus 1 would be negative 19 times the square root of 6. And then this last term, well, we know the square root of 4 is 2. 5 times 2 would be 10. So this would be a negative 10. Now we need to keep combining like terms. 12 minus 10 is 2 minus 19 times the square root of 6. Now what I want you to do is I want you to work through the rest of these. Be very, very careful with number 14. Make sure there's a common mistake that students make and that we've talked about before we went on spring break a lot. So just be very careful with how you proceed with 14. And unpause it when you're done and check your answers. Okay, you can go ahead and check your answers. For number 11, we get 19. Which other one did we not do? We did this one together. Number 10, you get 4 root 6 minus 4 root 10. We cannot do anything else with that. Neither of these radicals simplify. They both have a 4, but that doesn't do us anything here. Number 12, we have to distribute or FOIL here. So you take 2 and multiply by both of those, then the root 5 and multiply. We get negative 9 minus 3 root 5. Now, number 14, I said be very careful with. Common mistake is we try to distribute this 2 to both of those terms. Remember, when you have something squared, that means you have 2 of them. So we need to think of this problem as 4 minus the square root of 7 times 4 minus the square root of 7. Now I can do 4 times 4 is 16. 4 times a negative square root of 7 is negative 4 square root of 7. And then negative root 7 times 4 is negative 4 root 7. And last but not least, negative root 7 times negative root 7 is plus root 49, which we know is going to be 7. I need to combine like terms in the middle here. So I have 16 minus 8 times the square root of 7, and that's going to be plus 7. And so here we have 16 plus 9, or I'm sorry, not 16, 16 plus 7. 16 plus 7 gives us a 23 minus 8 times the square root of 7. And that is our final answer for that one. Again, make sure you're checking using your calculator. Type this into your calculator and type your answer. If you did distribute the 2 and you would have checked your answer, you would have realized it didn't work. Okay, the next idea here is rationalizing denominators with 2 terms. In the previous section, we saw that if you have to rationalize a denominator, you just multiply by whatever the square root or cubed root or whatever it may be that's in the denominator. But now we're looking at if there's 2 terms here. And we're going to call these a conjugate. So the conjugate of root 3 plus 2 is going to be root 3 minus 2. It's the same 2 terms, but you're changing the operation sign from plus to minus, or if it's subtraction, then you're making it addition. So the next thing says, are there conjugates in problems 9 through 14? Remember, conjugates have to have 2 terms. So this one only has 1. These 2 have 2 terms. Are they conjugates? Yes, because it's 5 and a root 6 in both of them. One's minus, one's plus. They have opposite signs. Are these 2 conjugates? No, because they have different numbers. This only has 1, it's not a conjugate. These ones have 2 terms, but they're different numbers. And this would also not be a conjugate because they're both subtraction here. So this one says multiply the conjugates. So let's go ahead and look at this example here. So if we have root 3 plus 2, and we want to multiply by its conjugate, root 3 minus 2. Well, root 3 times root 3 is root 9, which we know is going to be 3, minus 2 root 3 plus 2 root 3, and that would be minus 4. So this would be 3, and then you'll notice that when you multiply 2 conjugates together, these middle 2 terms will always cancel, just like they did in number 11. That's the nice thing about these conjugates is it gets rid of the square root. And then we have this minus 4 at the end, which is a negative 1 for a final answer. So the purpose of multiplying by a conjugate is it gets rid of the radical. So I'll do one of these with you, and then I'll let you try the other one on your own. So we want to rationalize each denominator. Again, you want to multiply by a factor of 1. Now we want to multiply by a conjugate though. Since it's 4 minus root 7, you want to use 4 plus root 7. Now multiply. So in the top one here, you have to think of parentheses around here, and you have to distribute that 3 to both the parentheses. 3 times 4, 12, plus 3 times the square root of 7. And now in the denominator, again, you want to think of there being parentheses and multiply just like you did up top. 4 times 4 is 16. And then you have plus 4 root 7 minus 4 root 7. And now I'm going to just skip this step. We know the last one, negative root 7 times positive would be a negative root 49, which is square root of 49 is 7. So now just to continue simplifying, the numerator, I'm going to keep that 12 plus 3 root 7 divided by, now we know these two terms are going to cancel. We're left with 16 minus 7, which is 9. Now the only other thing we can do here is we can simplify this completely. So if you notice that when we have this, you have three coefficients here. We have a 12, a 3, and a 9. All of them have factors of 3, so you could take a factor of 3 out of each one of those. So if we were to do that, we would see something like, you can write this a couple different ways. Just to write it longhand, just so you can see what we're doing. I'm going to rewrite 12 as 3 times 4, plus we have this 3 root 7 over 3 times 3. So you can see that I rewrote each of these numbers to have a factor of 3. Now what I can do here is go through and cancel out a 3 out of each one of these. And I'm left with 4 plus the square root of 7 over 3. And that would be our final answer. Again, if you have to rationalize the denominator, that means you need to rewrite it so there is not any radicals in the denominator. Go ahead and try number 16. Okay, you can see we multiply the top and bottom by the conjugate of 1 minus square root of 3. And as we continue to simplify, we know that each of these have a factor of 2. So I just rewrote 4 as 2 and 2, 2 and 2, and we can cancel a 2 out of each one of those. Then we'd be left with a negative 1 in the denominator. So I just simplified it as negative 2 plus 2 root 3. And that would be our answer there. Okay, well that's all at 10.5. Good luck on the homework, and please email if you have any questions.